In this video, we're going to look at a handful of examples where we analytically evaluate some limits. So we're going to jump right in. We're going to look at a problem and try to think about how we might approach this problem, each of those problems. So here we have the limit as x approaches 3 of x minus 3 over the square root of x plus 1 minus 2. The first thing I would ask myself is, does direct substitution work? Can I just plug 3 in and have that work? If we plug 3 in, we'll get 0 on top. That's not necessarily a bad thing. If we plug it into the denominator, we will also get 0 in the denominator. So that's problematic. So how might we deal with this problem? We need to do some work, do some algebra to try to get to a point where we can evaluate it. So what I would consider doing is multiply by the conjugate of that denominator. So square root of x plus 1 plus 2 over square root of x plus 1 plus 2. If we do that to both the top and the bottom, that top is going to stay x minus 3 times square root of x plus 1 plus 2. The denominator, if we were to FOIL that out, we will have x plus 1 minus 4. X plus 1 minus 4 is x minus 3, so those x minus 3's cancel. And at this point in time, if we do direct substitution, we will get the square root of 3 plus 1 plus 2, which is 2 plus 2, or 4. Great. So the thing about that problem that suggested to me that I might use multiplying by the conjugate is we got 0 over 0 when we tried direct substitution, and that denominator involves a square root. So that was a strategy that I considered there. In the next problem, we have the limit as x approaches negative 2, x squared plus 5x plus 6 over x squared minus 4. If we try direct substitution here, in that denominator we are going to get 0. The numerator will also give us 0. So what strategy might we try on this problem? Yeah, so let's try to factor it. So the top factors into x plus 3 times x plus 2. The bottom factors into x minus 2 times x plus 2. We have the x plus 2's that cancel. And now if we try direct substitution, we will get 1 over negative 4, so negative 1/4. Perfect. Let's look at another problem. So in our next problem, we have the limit as x approaches 1 of x squared minus 4x plus 2 over 3x squared minus 1. So how are we going to deal with this? Factor? Factor sounds like a great idea, except for I would always check direct substitution first. Just do a quick mental check, see if that's going to work. And on this problem, it turns out it's going to work. If we just substitute in directly, so I actually don't need to write my limit notation, because I'm going to substitute in directly, we have 1 squared minus 4 times 1 plus 2 over 3 times 1 squared minus 1. So we have 1 minus 4 plus 2, negative 1 over 2, or negative 1/2. Perfect. So don't get so into the habit of trying to cancel things that you forget direct substitution does work sometimes. And when it works, that is, I think, your quickest method. So I would take time to check that. Here we have limit as x approaches 0 of tangent squared x over x. If we try direct substitution, we'll get 0 over 0, so we need to do some work on the front end. So let's rewrite tangent as sines and cosines. It's being divided by x, so we can rewrite that as times 1 over x. Is this helpful? I don't know. I think so. I would use some of our special trig limits. So one of our special trig limits is sine x over x. So let's split this up in that way. So we will have sine x over x times sine x over cosine x. Is that helpful? What's the limit of this piece? Well, that is as x approaches 0. For that piece, as x approaches 0, that limit is 1. That's one of our special trig limits. For the other piece, if we did direct substitution, we're going to get 0 on top. Is that bad news? 0 on top is not bad news, as long as the bottom is not 0. And if we plug in 0 for x in that denominator, we're just going to get 1. So we have 0 over 1, which is 0. 1 times 0 is 0. So this limit is 0 itself. And finally, here we have the limit as x approaches 0 of sine 4t over 3t. If we try direct substitution, we'll get 0 over 0. Let's bring that 1/3 out in front. This should be t approaching 0. So we brought that t out in front, that 3 out in front. Now we need to get the stuff inside of 4t. We need that to look exactly like the denominator. And so what we can do is we can multiply both the numerator and the denominator by that 4. That 4 in the numerator I would bring out in front of the limit. And so we have 4/3 times the limit as t approaches 0 of sine 4t over 4t, which is just 4/3 times 1. Perfect. And that is how we go about evaluating some limits analytically. Direct substitution is a great tool that doesn't always work, but when it does, it's great. And if it doesn't, we have some other tools, some other methods that we might use. We will see you in our next video.